Hi everyone. We'll start soon. I I posted paper that we will be discussing in the chat, and yeah, we'll start soon. Thank you. Hi Katie. You wanna come up? How are you? Hey, how are you?
Hello. How are you, my love? It's good to have a room at a time. I'm awake. I'm excited for this conversation and good to hear and see you, my love.
Yeah, same here. I we haven't talked for a while, but yeah, I'm glad I could schedule a room in your time finally again. Thank you. I'm a little bit sick today, so my voice is not the best, but I'll try to do my best. We have around 5 minutes, so yeah, we'll start in 5 minutes. In the meantime, feel free to share the room, everyone, with people you think that would be interested, and yeah, we'll start shortly. Thank you.
Sorry to hear you're not well. Take care of your voice. I'm sure there's lots of people to help, and you're always such a great moderator anyway. And just type in the chat or anything if you need any support.
Thank you so much, Katie. Yep. Taking a lot of zinc and stuff, so we'll be fine soon. The regular cold. We are back in, being exposed to getting colds and stuff like that in the winter, so.
Oh, I already love the study that's in the chat below. Just having a quick glance on it. Really encourage everyone to look in the chat and have a look at the article scientific study that's going to be discussed today. Looks absolutely fascinating, and thanks for bringing in so many amazing speakers to talk about science, as always.
There you are. Hi, Isaac. Thank you for coming. We were just talking about your paper, how cool, how interesting it is. So thank you.
Hi everyone. Hi, hello. Can you hear me fine?
Yes, we can hear you.
Great, brilliant. Okay.
How are you today?
I'm good.
Sorry about
Everything is okay.
my voice is a little bit off. This is not my regular voice, but I'll do my best to sound okay.
Yeah, that sounds perfectly fine. Can people see the presentation? Just
Yeah, okay. I'll put it up now. 1 sec.
okay.
The paper is shared in the chat, so
Mm-hmm.
so access it. And
Yeah, I can see it.
here, there.
All right.
Yeah, should be working now. So
Okay. So we have like 3 more minutes, right? Before we
yeah,
have to. Okay.
exactly.
Great.
Hi, it's Katie. Dr. Fradkin, thank you so much for being here. Please take your time for a few minutes before we start. Just wanted to say welcome to Clubhouse and in the Science Society. Katerina hosts these amazing rooms, and there's always so many amazing questions. Just as you came in, I was nerding out about your study that's posted in the chat, and now we can all download the talk that you're going to give. So we're really looking forward to a really interesting conversation. I'm sure there'll be many questions, and thank you for sharing your time and your expertise with us.
Thank you. Thank you so much for inviting me and for having me and for yeah, I'm looking forward to hear any thoughts people might have about this.
Yeah, we'll start in a minute. So thank you everyone for being here. Hi everyone, and we are very honored to have our guest speaker here today. So feel free to share the room if you think this is something your friends or anyone would like to listen to. And we're just about to start. So yeah, thank you everyone for being here. And of course, a special thank you to Isaac here that took his time out of his busy schedule to yeah, talk about his really interesting research. And I think it's also really important for all of us. So yeah, I think we can start now. So welcome, Isaac, as Katie said so well. Thank you so much for being here. And before we start, um, I'll give a short introduction so people get to know you a little bit better. And if it's okay with you, we usually ask a few interview questions before we dive into your research.
Of course.
Perfect, thank you. So Dr. Itzik Fradkin, he is a postdoctoral researcher at the Hebrew University in Jerusalem, and he did his education at the University of Ben Gurion, University of Negev, until 2012. And then he was a clinical psychology student at the Hebrew University of Jerusalem and a PhD student also at the University of Jerusalem. And yeah, as I said, after all this education, he is now a postdoctoral researcher, and we will hear about the really interesting research you're doing here today. And a question we usually ask our guest speaker is, how did you choose the path of doing the scientific research? Was it something you always wanted to do? Was it maybe a class you took, a book you read, or something that sparked your interest to choose this path? Thank you.
Thank you so much for this lovely introduction. I hope everyone can hear me well. It's a really good question you're asking. I'll try to answer it briefly. Um, Actually, I started with interest in clinical psychology and being a therapist, and I indeed completed part of the route that clinical psychologists have to do to actually treat people with some practice and so. And along the way, I really got more and more interested in research, both from the methodological and the theoretical perspective. More specifically, and maybe using this to sort of continue to the topic of this talk. Um, Throughout my research career, and I assume that even before that, before I was yeah, was sort of able to define this thing as research, I became more and more interested in this thing we so intuitively call thoughts, which is something we obviously always experienced, and even though it's so intuitive to us and something that we know so well from ourselves, there really is not enough understanding um, of of course what thoughts actually are, but more specifically how thoughts work. So I will obviously not answer the first question, what thoughts actually are, today. I will barely answer the second question, but what I will talk about touches upon that, which is a question um, through which mechanisms, through which processes do thoughts work. So just one correction about my bio. I'm now a postdoc researcher at the Max Planck Computational Psychiatry Institute in London at UCL. And what I will present is mostly the study I've done in the Hebrew University, which is also the paper you see in the chat. But I've also discussed some additional applications we're using for the same general method uh, in other contexts in my current research.
Well, thank you for that. And it's really interesting that you this question about thoughts and thought processes and what they are. I think that's really interesting. And is there maybe for this project or yeah, for this project some sort of background story? How came it about? How did you manage to then actually do this project? Was it easy to convince people to get a grant, or yeah, is there some sort of backstory?
Um, yeah, I just have to recall what the backstory was. Um, so during my PhD, I studied obsessive compulsive disorder. And obsessive compulsive disorder, but also people who don't have OCD, often experience what is called intrusive thoughts. And this concept has always fascinating me, and part of my PhD was focused on intrusive thoughts. But to an extent, what I felt was missing in my PhD research is a better understanding of sort of how thoughts actually work. So most of my research up to that point, actually most of the research in clinical psychology in general, um, sort of views this idea of thoughts from two perspectives, either as um, trying to understand what people think from their introspection, from how they perceive their thoughts, or alternatively, from simply trying to infer what people think from what they say, from um, the way they express their thoughts. And what I was really looking for, and I am still looking for, is into having ways to try and tap what people actually think in as objective manner as possible, if that's a thing. And I think in a sense, the project, and even more so the method I will present today, tries to focus on exactly that. So should I just I think I just continue unless people have questions. I should say that if people feel midway that there's something that's very, very unclear, so please feel free to interrupt. And if you have more sort of broad questions that are not clarification, so we'll be happy to stay at the end and do it for as much time as needed. So if you have the presentation in front of you, or if you don't, you can see that the first slide, whatever, conveys a very, very non-exhaustive introduction into this idea of free association. So we're basically stepping from this very abstract idea of thoughts to the more concrete idea of free association. But starting from the very beginning of psychodynamic theories, but also cognitive theories in psychology, um, free associations and have been thought to provide us maybe a good glimpse into people, what people actually think. And even though this starts with Freud, um, the better example of the type of free association we're using today comes from Carl Jung, who was also a psychodynamic, famous psychodynamic analyst, therapist. And the reason for which Jung is more interesting in this perspective is that whereas Freud, when using free association technique, he basically asked people to just speak freely in a very non-restricted manner. Jung asked people for single word association. So he presented them with certain keywords. So, for example, in the slide, you can see the keyword head, and ask them to say only one association. And then one of the things that one of the intuitions he had about this very, very preliminary task, and I'll be citing him here, is the first thing that strikes us, Jung says, is the fact that many test persons, which is just people, show a marked prolongation of the reaction time. So the reaction time here would be how long it takes people to say in a specific association. This would seem to be suggestive of intellectual difficulties, wrongly, however, for we are often dealing with very intelligent persons of fluent speech. The explanation lies rather in the emotions. So the idea that, the intuition that Jung had here is that we can use not only the actual associations people give us, but also the reaction times to infer something about many different complex processes that have to do with emotions, with cognitive control, with semantic memory, and so on. That all of which sort of affect these two quantities, the association and the reaction time. Now, the main question we ask in this first study, which is also the paper you see, is can we use some of these principles to understand how people control their thoughts? And obviously, difficulties in controlling one's thoughts are a universal concern. It is also more prevalent in specific psychiatric disorders such as OCD, for example. Um, but yet again, like I said before, most of what we know about how people control their thoughts up to this point is based on their self-report, on how they report themselves controlling their thoughts, or on what types of thoughts they report or do not report. And one of the problems with this is that all of the attempts, successful or unsuccessful, to control one's thoughts on which people can actually report are by definition something we can call forms of reactive control. The idea here is that if people are aware to an attempt to control or to inhibit or to stop a certain thought, it means that this thought has already come to this person's mind. And the question we wanted to ask is, can people in general use what is known in cognitive science as proactive control? And proactive control here would mean, can people use any type of strategy allowing them to reduce the probability that a certain thought will come to mind in the first place? Now, to demonstrate proactive control in a way that it maybe makes more sense, think about yourself driving in a car. And let's say that you like standing with a car in front of a traffic light, and let's say that you want to continue straight, but then you have another traffic light destined for those who want to turn left that suddenly becomes green. In many cases, you will sort of pay attention to this event happening, to the traffic light becoming green, and you will need to inhibit this very automatic behavior of starting to drive. So this would be an example of reactive control. Something about the behavior already starts, and you have to inhibit it after it already started. But now consider something different. You're again in the car, standing in front of the traffic light, but then the traffic light, one of the traffic lights for the pedestrians becomes green instead of red, somewhere in your, like somewhere when you can actually see it. In many cases, you won't even pay attention to that. You will be able to filter that completely. And so this event will not trigger any automatic response of starting to drive the car or something like that, and therefore will not require any reactive inhibition. So the question is, can people do the same for thoughts? Can they, in some sense, prevent or completely ignore specific thoughts in a way that they don't even come to mind? I can see there are many questions in the chat, and unfortunately, I can't attend to them currently. So, if someone has a pressing matter, please feel free to interrupt. So, the way we examine this is using a sort of new free association task, where we simply showed people the same keyword, not one time, but several times. So for example, we showed people the keyword table 5 times, not one after the other. There were other keywords in between, but still 5 times. And we asked participants in one group to avoid reporting the same association twice. So in the on the second slide in the presentation, if you have it in front of you, we sort of envision this process where the first time people see the keyword table, they write or they say chair, but then the second time, people in this suppressed group were asked not to say chair again, and they had to come up with a different association. And the question is, how do they do it? Do they do it using reactive control or proactive control? In other words, do they have to first think the association table and then to reject it and replace it, which is reactive? Or can they avoid thinking the association table for the second time altogether, and therefore they can more efficiently think of a different association? One of the empirical predictions of the difference between these two mechanisms has to do with the reaction times. So let's say that people in the second time report not chair, but actually, do the task well. They report a different association. So for example, the association desk. The question is, how long does it take them to say or to write this new association? Under the reactive control hypothesis, one of the most basic predictions is that it will take them more time than what it took them to report the first association to the word table. And the reason for which it would take them more time is because they have to think of this first repeated association, to reject it, and then to come up with a new association. And this is a process that is, to some extent, effortful and takes time. So just to sort of reiterate, under reactive control, we expect these new associations to repeated cues to be prolonged in or delayed in their reaction times. Conversely, under proactive control, we might expect either no such prolongation of reaction time, so people can either be as fast, or we have even a good reason to believe that people might be faster if they use proactive control. The reason for that is because when we try to come up with an association, we basically have many, many different associations competing. And this competition by itself, it is something that takes time. And if people are able to completely filter out the previous association table from their sort of memory, that means that there's less competition between less associations. And if there's less competition, we might expect the response to take less time. So the basic prediction here would be prolonged responses to new associations would be evidence for reactive control, whereas the same speed or facilitated responses would be evidence for proactive control. On the third slide, we can see the actual results, and the results show us that specifically in the suppressed group, there's a considerable difference between the time it took people to say a new association to a repeated cue than the time it took them to say the first association to on the first time this cue was presented. And we see basically prolongation. And this basic result, as I implied before, seems to suggest that people mostly use reactive control over their thoughts. So at least when we look at behavior, we can see no evidence for proactive thought control, no evidence that people are able to filter out completely unwanted thoughts, unwanted associations. However, we took one step further, trying to understand in a more detailed manner what exactly is happening. And we did this with something that we can call mathematical or computational modeling. The basic idea behind mathematical modeling in cognition is that we formalize set of equations that obviously do not fully reflect the very complex cognitive process that is going on, but tries to approximate some components of this cognitive process. And this computational model, the one we used, was based on the associations people reported and on the reaction times, and it had two key variables, two key, we call it parameters. And these parameters convey exactly these two mechanisms I mentioned before. One of the parameters, which we call associative strength modification parameter, is a parameter that tries to examine after people see the word table and say, let's say, chair for the first time, what happens to the strength of this association chair? Does it becomes weaker, suggesting proactive control? Does it stay the same? Or maybe it becomes stronger. Maybe after saying an association for the first time, it becomes stronger. In other words, maybe after we think a certain thought, the probability that this thought will recur again in the same context increases. The other parameter is simply the thought rejection parameter, and it simply quantifies the probability that after a person actually thinks about repeated association, what is the probability that this person will reject this association and try to come up with an alternative? On the fifth slide, we can see the results. So the first very not surprising results is that people in the suppressed group compared to people in a control group, and I didn't say that before, but people in the control group were basically um, they did the same task, but they were not asked to suppress repeated associations. They were not asked to report them as well, but they were free to do as they choose. So the first very expected finding we see is that people in the suppressed group had a higher rejection probability. They had a much higher probability of rejecting repeating associations, so much higher reactive control. The second thing we see is that the associative strength modification parameter, for which we use the Greek letter rho here, is positive in both groups. And a positive parameter here would mean that in both groups, saying an association or writing an association increased its strength in the short term. In both groups, in other words, thinking or expressing a thought made it more likely to recur. However, so this again shows us that there's no full proactive control. There's no ability to reduce the strength of repeated associations. However, another very intriguing finding is that for people in the suppressed group, this increase in the strength of repeated associations was not as strong as it was in the control group. In other words, even though in general having a thought increases its strength, it seems like people have some proactive control over the extent to which this happens. On the sixth slide, we see why this might be important. Specifically, what we see in this on this slide are correlations between the two parameters and between a self-report scale called the thought suppression inventory, which basically measures people's self-reported ability to control unwanted thoughts in their daily lives. And what we see is that first, people in the suppress group who were better, who reported being better at sort of controlling their unwanted thoughts in their lives, were also better at rejecting unwanted associations. But the second very intriguing thing that we see is that even for people in the control group who were not asked to suppress associations, this associative strength modification parameter was correlated with how well people actually suppress thoughts in their daily lives. And what we see here is that people who are better at suppressing unwanted thoughts in their lives also show reduced um, reinforcement of repeated thoughts, of repeated associations. So to conclude this basic idea, what we found is that as a most sort of general finding, people, when we measure in an objective manner based on reaction times, how people control their thoughts, people mostly use reactive thought control. People mostly have to sort of think a thought in order to be able to reject it. However, we also found that people are able to make sure that this unwanted thought will not come to mind as much as it otherwise could have. And this happens not because they can weaken its strength, but because they can make sure that it does not become overly or excessively strong over time. I think that this really speaks of um, an experience that might be familiar to us all in the sense that sometimes thoughts, unwanted thoughts, can become so upsetting and stressing and maybe even debilitating because they become stronger and stronger over time, and we sort of can find ourselves stuck thinking the same thought, being unable to exit this loop. And what we found here is that in general it seems like people have some sort of probably automatic mechanism allowing them to make sure that this self-reinforcing effect of thoughts is not as strong as it otherwise could have been. Um, right. So the next parts have to do with a slightly different study. So I think that I will pause for 5 or so minutes to see if people have any specific questions about this first part before continuing to the second part.
Hi, it's Katie. Just wanted to say absolutely fascinating, Dr. Franken. There's a lot of, I know you can't multitask while you're giving a presentation. There's a lot of really fascinating questions in the chat. I don't think anything is so pressing at the moment, but just for anyone that is in the audience and you want to come up and ask a question, you're more than welcome to raise your hand and we will bring you up. Otherwise, we'll relay the questions at the end of your presentation. Thank you so much.
All
Hi,
right.
Jeremy.
Yeah. Hi.
So I had a question about what you were just speaking on. You said there either was or might be a mechanism for this, and I was curious if that might be the Maslow's hierarchy of needs.
I'm sorry. I think I
Okay.
lost you. Maybe it's my
No,
maybe it's my
no,
connection.
I'm terrible at asking questions. So you were just speaking about, if I could bring up the slide, then maybe, because I wasn't looking at it, I was getting dressed. Maybe it discusses it there, but associative anxiety, I don't see it. You were just speaking about thoughts getting stuck in someone's head, um, and there being a mechanism for that. And I was just wondering if you could speak more to it. I had an idea, but I wanted really just if you could speak more to it, that'd be beneficial.
Right. So in a sense, I mentioned two mechanisms that are related to that. The first is the mere fact that it seems that universally, when we think something um, in a specific context, this thought becomes stronger, at least on the short term, right? The way we see it in our task is that when people, we show them the word chair, they come up with the association, sorry, we show them the word table, they come up with the association chair, let's say. Um, the strength of this association strengthens at the short term, making it more likely to recur than it was in the beginning. The second mechanism, which is more novel and more interesting, I think, is that when we take a specific group of people, asking them to, in a sense, control their thoughts, these people do show some implicit ability to make sure that this mechanism I mentioned, the self-reinforcing mechanism, is to some extent mitigated and is not as strong as it otherwise could have been. Now, we don't fully understand how exactly people do that, but it seems, logically speaking, that this this sort of partial proactive control mechanism cannot be very effortful, because if people were trying to very effortfully control their thoughts, um, it couldn't have helped them mitigate the increase in its strength over time. So we suspect that this is some sort of an automatic mechanism. In other words, by simply knowing that your a certain thought is an unwanted thought, it is something that can be enough to um, to activate this automatic mechanism that makes sure it does not become overly strong and overly excessive over time. But again, we definitely need more research to understand how exactly this mechanism works.
And to my point, I was asking if that might be like related to Maslow's hierarchy of needs. If that's what possibly brings the ideas to the forefront that you then have to either swipe away or otherwise do away with.
I don't know. The truth is, I don't know exactly. It's an interesting question, but yeah, we need some concrete way to actually examine this.
Thank you.
Hi, it's Katie. Thanks so much for the question, Nerdish, and also welcome to the stage, amazing Dr. Roshanak. Really grateful to have you here. Please go ahead and share if you would like to.
Thank you so much, Katie, and hi, everybody, and thanks for the ping, Katie. I would have been very disappointed to miss this room, and unfortunately, I did miss the early parts, but I'm wondering if what Jeremy's asking is related to attention and emotional control. So I'll ask a question that's somewhat in between both of those, which is, I don't know specifically because I did miss the beginning, unfortunately, and I'll listen to the replay. When you're talking about the proactive, so what I'm thinking of is, we fall into, so statistically, right, about 95% of our thoughts are repetitive, right? And about 80% are negative. So that emotional state goes into the dorsal medial prefrontal cortex, typically when we think about rumination and these repetitive thoughts and sort of out of control repetitive thoughts that people don't want, the negative ones. And considered thought in the DLPFC mitigates that. So when you're looking at those people who are better at the proactive, have you been able to, and I know you just said that you are looking deeper into the mechanisms, have you been able to see what that has to do with respect to like the ACC, habitual responses, impulse control, and then the effect of the limbic system on this, right? Because also depressive thoughts go into the DMPFC. So I'm just wondering where you might be along that pathway.
Yeah, thank you. It's a really really interesting question. One that we have not examined yet. The study was merely behavior. We didn't do any imaging. Um, One thing I should sort of, my hypothesis would be that these traditional inhibitory mechanisms, at least some of them, not sure about the DLPFC, but maybe the inferior frontal gyrus, for example, as a brain area that is involved in inhibition, would correlate more with what we called here reactive thought control. Because what happens in, I mean, it's a good question of what happens in the proactive thought control. What exactly happens at the brain that allows people to, that sort of
Right. Is it just a
changes,
redirect? Mm.
yeah, changes, exactly, changes the basically the semantic networks online, right? Changes like the dynamics or the dynamic structure, if I may call it that, of the semantic networks online according to one's goals and according to the task and according to their recent history. And I would suspect, therefore, that anything that should have to do with proactive thought control would be found in the more basic semantic or semantic control mechanisms. So sort of mediotemporal and so on. But this is definitely something we're want to examine. Right. So I think that thank you for this very very interesting questions. I think I want to take the next 7-10 minutes to present the second part, and then we can have a broader discussion about both of them, about the first or about the second. So one of the key sort of ideas that we try to capture here, and we partially succeeded, but only partially, is this distinction between what we think and what we eventually express. And we try to examine how people are able not to express specific associations. Is it through reactive or through proactive thought control? This basic question of the possible dissociation between what we think and how we speak or what we express is also very relevant to another type of we can call it psychiatric phenotype or psychiatric phenomena, and this phenomena is traditionally called formal thought disorder, and there's some very prototypical example on slide 7. Formal thought disorder is usually diagnosed in the context of psychosis or schizophrenia. Some studies suggest it to be as prevalent as in 50% of people who have schizophrenia or psychosis. It is defined as some disruption in either language or thinking, and the most prototypical example would be this sort of incoherent speech or disorganized tangential speech. And this is so the example that I show here on the slide is from an interview where the let's say the therapist asks a patient, "What city are you from?" And then the patient starts answering, "Well, that's a hard question to answer. I was born in Marburg, but my parents met in Cologne. This was a hard time. They had to go through many financial difficulties. It was during the war, and we had to flee from the city." And this is just one type of example showing us how speech might become tangential, sort of lose the original point, and to an extent become incoherent. On the slide, you also have a link to a very very good YouTube video by someone who, a woman who basically sort of describes her experience with schizophrenia in a very accessible and brilliant manner, I should say. And this specific video is about her experience with scattered thoughts and thought disorder. Now, the reason for which this whole model I showed you is relevant for thought disorder is because we don't really understand, we as clinicians, as researchers, we don't understand what explains such incoherence in speech that we see in schizophrenia, but we might also see in even in a more mild form in other types of phenomenology. So there were some previous suggestions about ADHD, for example, about autism, maybe OCD is somehow related to that. And the thing that we don't understand is whether the problem lies in whether people who at times find themselves speaking in a somewhat less coherent manner or maybe less organized manner, is it because their thoughts are also disorganized? Or is it actually because the deficit lies in the ability to control or to filter the types of maybe normal slippages of thoughts that we all might experience, right? So does this patient in this specific example, was it just a difficulty in inhibiting this derailment of thought? We see these details about the financial difficulties in the war, and maybe other people might sort of have these thoughts as well, but might be better at inhibiting, not expressing them, or is it really about the level of the thought? And in this second study, we examined this question in a very large general population study. So it's not a clinical study, not a clinical sample. We deliberately wanted to examine how this idea of formal thought disorder is organized in the general population. And the way we did it is we administered a bunch of psychiatric questionnaires and examined what we call a factor structure. I mean, the way they are organized in the population. And then we examined for each of the latent psychiatric dimensions we found whether it shows any type of disorganization or atypicality in speech or in writing or in narratives. And if so, what can explain that? So on the 8th slide, you can see a demonstration of the two mechanisms I discussed and examined in a free association task, but here associations are given to color rather than to specific words. So let's say that we ask people just to say whatever association comes to mind to a specific color. And what you see on that slide is two potential mechanisms. On the top mechanism, formal thought disorder. So, for example, expressed in the fact that people, when seeing these sort of bluish color, instead of saying the more typical, stronger association sky, they might say the association pillow, for example. So, is it because their semantic maps or semantic networks are sort of more stochastic, more dispersed, less constrained? Is it at the thought level? Or is it because, as shown at the bottom illustration, because they're less able to reject these sort of loose associations that might come to everyone's mind at the same degree? And so basically, the model I have just shown you that does exactly that. It allows us to dissociate the processes that affect the type of associations that come to mind from the processes that control the different filtering, control, or executive regulation processes people use to decide which associations to report and which not to report. What we found is really quite fascinating, I think. We found a bunch of psychiatric dimensions, but I will present here only 3 of them because they showed a very different sort of pattern of results. The first psychiatric dimension that was relevant, and I'm now on the 9th, on slide number 9. We called it self-reported eccentricity because it literally includes items where people say about themselves things like, I talk in ways that other people find strange, I use long and unusual words to say simple things. We found that people who say such things about themselves indeed produce more atypical associations in our free association task. And we also asked them to produce a free sort of narrative. and their narratives were also slightly more atypical. Examining using the model what causes such atypical associations indicated across two replications that it was mostly about the level of the actual thought or the constraint or organization of the actual thought rather than at the level of inhibition. So it suggested that at least in this sort of psychiatric dimension, atypical language is the result of slightly less organized or less constrained or maybe more stochastic thinking or associative processes. Now, the reason for which it is so interesting is that we found two other psychiatric dimensions with a completely different pattern. The second psychiatric dimension shown on slide 10 is something we can call social anxiety. And it includes items such as I get anxious when meeting people for the first time. Sometimes I avoid going to places where there will be many people because I will get anxious. Now, I should say that the psychiatric dimensions themselves, they're positively correlated. In many cases, people who have higher social anxiety, not in many cases, but in general, people who have higher social anxiety have a slightly higher tendency of having a higher self-reported eccentricity. However, the pattern of results we found was completely the opposite, in the sense that people with high-end social anxiety produced more typical narratives. And their organization of the associations was more peaked, less stochastic, and more constrained. The third dimension I wanted to present is something we call suspiciousness. It includes different items that have to do both with actual suspiciousness, being suspicious of other people's intentions, but also in just difficulties at sort of disclosing one's feelings to other people and so on. So for example, included items such as I often have to keep an eye out to stop people from taking advantage of me, or I find it hard to be emotionally close to other people. What was so fascinating about this dimension is that it did not show more or less atypical narratives or associations. It showed, at least not significantly so. However, when we examine the processes using the computational model, it showed us that the reason for which we don't really see very atypical associations in this group is not because they don't think of atypical associations, but rather because when they think of atypical associations, they use increased control or filtering mechanisms to make sure they don't say those associations out loud. And we see this at the bottom plot in the sense that we can see that the associative constraint parameter of this group is similar to the one of the eccentricity group, but then the executive regulation parameter goes to the other direction, to the positive direction, suggesting increased regulation. So what I find so fascinating about the study is that we have three psychiatric dimensions here, all of which are to some extent positively correlated to one another, all of which are related maybe etiologically to different difficulties in maybe social history or maybe different experiences in the social world. It could be different things like isolation, bullying. We don't know. We didn't examine these specific things, but the pattern of use of language and thought we see is remarkably different, potentially is telling us something about the coping mechanism people use in order to deal with either current or past difficulties, interpersonal difficulties. Do people simply accept themselves being different, as in self-reported eccentricity, and just report different associations, different narratives? Do people really, really try not to be different, and therefore they produce excessively, in a sense, typical narratives? Or do people know that they're somewhat different, but try to hide it because they don't trust other people, which is what we might see in suspiciousness? Yeah, these are again, there's so much more to be done here to actually establish and explore these findings. But in general, it just shows us how this type of mathematical modeling in a very simple free association task can teach us many interesting things about this interaction between how we think and how we control both our thoughts and the way we express them. Yeah, that's it for my part. Thank you.
Hi, it's Katie. Thank you so much, Dr. Franken, for a really, really fascinating talk. I just want to also welcome everyone that's come and joined us in the room as well. If you have missed the earlier part of the conversation, this will be on replay, so you're welcome to listen back and hear the rest of the conversation. Otherwise, both in the chat, there is a link to the scientific research study published paper, and also a link at the top of the room to the PowerPoint PDF that Dr. Dr. Franken, sorry, has just run us through. So thanks everyone for being here in the Science Society. Again, thank you for an amazing conversation. Really grateful also to have Nerdish, and of course, thank you, Katerina, for facilitating these amazing conversations as always. And we have the amazing Dr. Roshanak, who is also a neuroscientist. So also perfect to be here on stage. Thank you everyone for all the shares to the room. Really, really great to see so many people here, and the chats and the discussion. We will relay chats and the discussion, but in the meantime, if anyone is available and would like to come up on stage, you're more than welcome to raise your hand, and we will have a bit of time to answer questions. So thank you so much again for being here. Really, really fascinating research, and grateful for you to share it with us.
Thank you. Thank you so much. Happy to, and I'm happy to take questions.
Yeah, thank you so much for this amazing talk. I agree with Katie. This is I really appreciate, how systematic and that you use computational models to get to the bottom of this, basically, of these thought processes. I think that is fascinating and a really great way to look at this. And I kind of wanted to ask you, how do you think, maybe, for a general question for a general audience, so how do you think people can maybe use this insight that you presented to us in everyday life? Do you have maybe it's a bad question, but do you have something for people in everyday life to kind of take away from how to control their thoughts?
Yeah, it's definitely not a bad question. It's an excellent question. It's a super important question. I'm afraid I don't have a good answer. That's the problem. I wouldn't dare to offer something that is not scientifically established. And I should say that we are examining or planning to examine, using the first task I showed you, what different instructions or different manipulations can help with either proactive or reactive control. One intuition I would like to stress that I hinted at before is that my interpretation, practical interpretation of these findings, is in a sense that trusting our brain, if we might say so, or trusting the automatic processes that are in place to do some of the thought control work for us in a non-effortful manner, um, is something that seems to be implied by by this very partial proactive control ability we found among participants. So we do know from a lot of previous studies that when people try very effortfully to suppress their thoughts, this either doesn't work very well or works for a very short time, and then we see sort of a rebound. We also know that by having some sort of a mindful, accepting state of mind of allowing thoughts to just flow freely, trying not to intervene too much, is something that can actually help with the experience of repetitive unwanted thoughts. I want to believe that our study suggests that one of the ways through which such acceptance, or maybe not intervening with whatever happens by itself in the terms of thoughts, helps is by allowing this automatic mechanism of very partial, again, but still proactive control to act. And it might be the case, but we still need to examine this, so it's an hypothesis, not a result, that if we were to ask people to very effortfully suppress repeated associations, we would have seen we would not see the same ability to mitigate the extent to which thoughts become self-reinforcing. So, yeah.
Yeah,
So it's not very concrete, but it suggests like a direction that sort of is consistent with previous literature in terms of um, just trusting the automatic mechanisms that can do some, at least, of the hard heavy lifting for us.
yeah, that's interesting. Thank you for that. And what about stress control? Did you ever test, or are you planning to in the future to test if when people are in a very stressful life phase versus then in a less stressful, or using all these de-stress techniques, if maybe the association timing of negative versus positive um, associations kind of change with diminished stress levels?
Yeah, it's a very good question. We definitely plan to. We have so many questions we still need to examine. We need to examine first all the associations in this task were completely neutral. I mean, we didn't use any negative keywords, so we need to examine whether using negative keywords will have show a different pattern in results. Then we need to examine whether, again, different state stress or state anxiety, which is what you referred to, affects or moderates our effects. And then at the end, we have to examine how different micro interventions, if I may say, that people use or recommend on, how do they affect these processes with negative or neutral thoughts. So there's so much more to examine here, yeah.
Yeah, I understand. That's always the most exciting work, I think, that leads to so many more projects and questions to answer. So, congratulations again. And yeah, please flash your microphones. Maybe go in PTR order for everyone that has questions and came to the stage. Welcome. And yeah, please go ahead. Thank you.
Shiraz, did you have a question?
Oh, sorry. So, hi, Isaac. My question to you is that, you talked about we have to preempt our thoughts. We have to stop them from coming. So, what I wanted to ask you that how do we stop these thoughts to have an emotional impact on us? I don't see that there's anything wrong with having, lots of thoughts. There could be a deluge of thoughts, but how do we stop these thoughts from having an emotional impact? For example, even if I consider many scenarios, it doesn't have to have a negative impact on me. I could just observe them and they are there, but why should I be flustered or feel anxious about them? Why? How to decouple emotion from thought? That's my question. Thank you.
Yeah, it's an excellent question, Shiraz. Thank you so much for asking it, for two reasons. The first is that um, it always, I mean, I really, it's really important for me to stress that I did not imply, nor do I try to imply, that what our study or the main question we ask implies is that we need to prevent our thoughts from coming to mind or need to preempt them. I believe that what we've shown is not really at this level of we need to do something to prevent thoughts from happening, but rather suggesting that we already have mechanisms working automatically to do that for us. So I wouldn't want people to sort of fear their thoughts and trying to preempt them because of that. That was not my intention at all. As regarding your second question, which is again an excellent question, it is not something we examined. It is again something we need to examine in the future in this task. But we know from other studies and clinical studies that as with every strong emotional response or fear, allowing oneself to experience this fear or the thoughts all the way through. So that does not mean sort of ruminating about specific issues. That means allowing even negative thoughts to come to mind, and even the negative emotional response to be experienced to the full is something that can reduce the emotional response over time. So so the same way in which if someone is afraid, or let's say of of spiders, um, uh, the more this person will sort of get closer to spiders, allow oneself to hold a spider or touch a spider, or I don't know, but for a prolonged period of time, not for 1 second, it is something that can, I mean, you will see an increase in the emotional response at the short term, but then we usually see a decrease in the emotional response at the long term. We think the same way about unwanted thoughts, that experiencing them and their emotional reaction to the fullest allows them to sort of become not as dominant over time.
Well, there's one thing here I want to state. I have read some papers where they had examined patients who were who had some lesions in their orbitofrontal cortex, for example. And when they were put in, they were able to control their thoughts more proactively because they did not freeze in situations. So is it also related to our limbic system? Like if you are able to have less freeze response, would that give you an enhanced ability to proactively control your thoughts, Isaac?
Yeah, I don't know. I mean, I don't know. Certainly, there's no way in which we can, lesion people's brain in order to make them have less feelings. Um, I, what I'm suggesting is in a sense a bit of the opposite. That when we allow ourselves to experience our feelings all the way, not ruminating about them, not getting stuck, but to being as elaborate as possible, with these feelings will become more and more tolerable over time.
Thank you.
Hi, it's Katie. Thanks for a great question and the great response as well, Dr. Fradkin. I think you touched on that really well in your presentation as well, that it's, in fact, the rumination and when it comes to conditions such as OCD. And thank you also for being really open about your journey. I wish that we can all normalize as scientists having different health and mental health conditions and ADHD and everything like that, as when, it's the rumination of thoughts, not just a thought entering its head and entering your head. So thank you so much. Really appreciate it. And just wanted to, I see that Path would like to speak, and Siva and Shimi, we see you as well and would love to hear your questions. So Path, please go ahead.
Yeah, thank you very much for doing the room and inviting me on stage. I really enjoyed this room, though I joined a bit late. So I have more questions, more than questions, like some thoughts and comments based on my limited understanding. I'm not a psychologist or a behavioral expert. Two examples come to mind. One is the example of I'm looking at the big picture, no, of the neuroscientist James Fallon. I think he's an American neuroscientist, who was examining the PET scans of tens of hundreds of psychopaths and he finds that eventually he makes this startling, shocking discovery that the scan with the most neural correlates showing psychopathy was his own, which he used as a control. And then he did a little bit of digging. So there, he's quite popular. He's quite famous in this particular context. He goes on to say that he is a non-violent psychopath. In other words, he had all the neural correlates as well as a variant of this. I think it's a gene involved in the serotonin pathway. And technically speaking, he could have very well become a psychopath, but he makes this compelling argument that he did not turn out to be a psychopath because of his upbringing. And his hypothesis is that one may have the genetic mechanisms to become a psychopath, but it's like the bullets in a gun. Whether you shoot it or not depends on so many environmental factors. I think that was quite very revealing, the kind of hypothesis he has made. That is one example. On the other hand, we have the example of Charles Whitman, who had a brain tumor in his head. He didn't know, and he was suffering from bouts of extreme anger and violent behavior, which eventually led to him. I think he killed a number of people, and after his, I think he also killed himself. Let me just dig up, and then they found that he did have a tumor in his head, and that was impacting his behavior. So I think it's a very complicated, multi-layered topic. Free will versus how much do we have control over our thoughts and behavior. That's a bigger picture. I think one can also delve into philosophies like Stoicism, and I think somebody mentioned Maslow's ideas, theories, right? All these things come into play, but the one specific question I have, and I've been rambling on to Dr. Isaac, is how much does childhood upbringing, being raised in a good family and values imbibed, have a role in all these things, in human behavior in adulthood? Thank you very much.
Thank you for that, Parth. Yeah, you're asking me a question I can't answer, not in this general sort of sense. There have obviously been so many studies asking a similar question in many different contexts, and we know by now that even though genetics are very important in most psychological or psychiatric dimensions or phenotypes, the nurture, whether it's bringing it home or social environments or environmental factors, all of these things have a great impact. One very small thing I want to say is that concerning the second study I presented, not the first study, this, I mean, it's not a finding that we directly had, but it did surprise me very much that we had 11 psychiatric dimensions overall, and the 3 of them that showed some alterations in language or thought were dimensions that have to do with interpersonal difficulties, some of which are likely also related to some interpersonal difficulties in social environments in early life, and yeah, so it is something that is sort of everybody knows in psychiatry, in psychology, but in psychiatry it is often it is sometimes sort of missed when sometimes people think about thought disorder, then think about this as some sort of a brain impairment that causes one to maybe be incoherent in speech or thinking, but our findings speak of and relate to previous findings, suggesting that this also has a very strong social interpersonal component to it that we ought to understand much more about.
Yeah, thank you very much. Just one quick follow-up comment rather than a question. I think we are still yet to completely, I'm sure most of us would agree with that, we haven't completely understood the neural correlates of human behavior, and the issue of free will versus genetically predetermined behavior is going to be will continue to be a Pandora's box in the future. I just shared some links in the chat section because I have anecdotal experiences from people, from families. Two children raised in the same family, the same value system, same environment. One child becomes, a criminal, the other doesn't. Why do such things happen? And they're all, one can always assume that these are outliers of examples, but when there are more than a few handful, that raises big questions. So, but again, thank you again for this room. It's very interesting room. Thank you.
Hello. Hello, am I audible? Hello, am I audible?
Welcome.
Yeah.
We can hear you now. Please go ahead and ask your
Okay, thank you.
question. Welcome.
Thank you so much for that, your precious time. I would like to ask one question. We know that mind will react spontaneously for involuntary retaliations. That mechanism, is it possible that mechanism for unwanted thoughts? And why so if it is not, if it is a different mechanism? So how do we compare these two mechanisms are different? So this is my question. Thank you.
Sorry, can you repeat the first part? How do we compare the mechanism of unwanted thoughts
Mechanism,
versus which mechanism?
mind will react for spontaneous involuntary retaliations. I mean,
What do you mean by involuntary
yeah,
retaliation?
involuntary retaliations.
Can you give
Same
an example,
mechanism.
maybe?
Why? I mean, if mosquito some bites, then immediately without spontaneously we react like that. So short time retaliations will happen, right? So that mechanism is why it is different, and why mind cannot apply that mechanism for unwanted thoughts. So that is my question.
I'm sorry. It's probably me. I still not sure I understood what you mean by retaliations exactly. Can you give maybe a concrete example of something like this happening?
And for example, if we are going and suddenly some things will happen and we react, right, for that incidents. So those are short-term incidents. So and what is that mechanism? And that is that different from what we are discussing now?
Do you mean like behavioral reactions? How do behavioral reactions differ from thoughts?
I mean, sudden reactions, I can say simply. Involuntary
Sudden
retaliation.
reactions?
Yes. Mind will react
Uh,
very quickly for sudden reactions, right? So those we can just say involuntary retaliations. So same kind, that mechanism is different for our present discussion, or is both are same? That is my question.
Okay, I'm not sure I still fully understood. I apologize for that. So I just want to very briefly say that one of the assumptions of the first study I showed is that this distinction between proactive and reactive control, which is known mostly from behavior and maybe from something you can also call these immediate automatic reactions. So whether people, so I gave this example of standing at a traffic light with a car, and then whether we can completely filter out unrelevant, like traffic light becoming green, or do we have to sort of first process it and then sort of try to ignore it after, as an example that might count as an immediate reaction. So the assumption is that these two things might have shared mechanisms, but I don't know, maybe I did not explain the question. So if you have any follow-ups, feel free to maybe email me or write something, and yeah.
Okay, sir. Thank you so much.
Thank you so much. And I just want to do a quick check in with you, Dr. Franken, about your time. We've got Shimmy and Kyle on stage with questions, but others in the chat just wanted to check. We just honour your time and don't want to take up too much, so just let us know how long you're available for, please.
No, it's totally fine. I have like 15, 20 more minutes, so I would be happy to answer all questions. If unfortunately I can't really sift through the chat, so if yeah, if someone wants to ask their chat written question out loud or something, that would be better.
No problem at all. I just wanted to say, Shimmy, would you like to ask a question? Otherwise, I will sift through some of the chat questions as well.
I just had that'd be great. A quick question. Thank you, doctor. In terms of looking at eccentricity, social anxiety, and suspiciousness, I was trying to go through the slides. Do those three correlate with a greater, like a more pronounced population of proactive and reactive thought control? Like, do you find social anxiety to be more representative of proactive thought control, or how do those interweave?
Yeah, yeah. Sorry, it wasn't very clear on the slides because slides on Clubhouse are always like very, yeah, it's difficult to understand them on their own. No, so this was a different study in which we did not examine proactive thought control at all. It only examined, in a sense, reactive thought control because it only examined the two mechanisms we examined there, the first of which was not really about control, was simply about the dynamics of semantic retrieval. I mean, how organized one's semantics networks or maps are, or versus disorganized in the sense of being very stochastic. And the second was a reactive control sort of process. So what we found there is that, for example, eccentricity was characterized by slightly more disorganized semantic maps. Social anxiety was characterized by more organized, so less stochastic and more predictable semantic maps, more typical semantic maps in a sense. And suspiciousness was characterized by the very interesting combination of less typical, slightly more stochastic semantic maps with increased reactive control over what association people actually say out loud and which associations they keep to themselves.
Okay, great. Thank you. And then was the age group all like 18 and up, or did you take in account for when people first started experiencing obtrusive thoughts?
Yeah, so in both studies, the age groups were adults, so 18
Okay.
and up. Yes.
Okay, great. Thank you.
Sure.
Thank you so much. I was just going through the chat, and let me just go back. It's not it's not very coherent for me to multitask. But let me relay one of the last questions. So, are you saying the more that we expose ourselves to fearful situations, our emotional reaction intensity will reduce over time? Thank you so much.
Right. Yeah. It was something I said. It was not directly related to any of the research I did, I presented. It is basically like a very common finding in anxiety research in general, for example. Yes, generally speaking, the more, if we have something that invokes a fear response, usually the more we expose ourselves to that thing fully, the lower will the fear response become over time. There are some important subtleties in terms of how to do such exposures, right? So whether to, for instance, let's go back to the very simple spider phobia example. If I had like a fear of spiders, and then I would just very briefly sort of touch a spider and then move my hand, that will not help reduce my fear response because I escaped the fear very quickly. But if I were to hold the spider in my hand for a prolonged period of time, as difficult as it sounds, this will almost universally reduce the fear response. Yeah.
Great, thank you so much. Yes, I've heard of exposure therapy for things like fear of flights and I guess spiders and other fears that we might have. So that's perfect. I'm just going to take a moment again to sift through all the chat. Thank you everyone for all your great questions. As Dr. Franken will have to leave shortly, this is your last opportunity to please raise your hand and come up and ask a question, or please type it in the chat and we can relay it. And also welcome to listen back to the replay, and please just give me a moment to go through the chats. I can't seem to be able to speak and go through messages at the same time, but thank you so much. Please go ahead, Katarina.
Yeah, thank you so much, Katie. While you do that, I wanted to just comment, or maybe, Isaac, you have like a response to that comment. You know, in the back channel, some people were texting me, and I think sometimes it's really interesting how sometimes simple analysis methods work much better to analyze our complex mind than very elaborate ones that you some people come up with, and they are not very effective at dissecting out symptoms we have. Like, this timing method is so elegant for such a complex problem. Like, do you see that pattern also, that sometimes these things work way better?
Yeah. It's a really good question.
So
I
that's
think,
what I mean. For example, you could come up with where your eyes are and how your posture is, and analyze all the face muscles with AI, and you probably
yeah.
wouldn't get such a elegant result, like way of testing it, and a clear result like this.
Yeah. I it's a very complex and broad question. I don't know how to start the answer. I think that I'm reaction times seem to be a very simple thing. Even reactions, right? Even like associations seem to be a very simple thing, and the free association task seem to be a very simplified, very, 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 very simplified version of this very complex idea we call thoughts, right? Yet again, even though associations and reaction times are such a simple thing, when we try to understand, I think the thing that excites me the most is that we try to really get into this and to really understand the mechanism of what actually happens, and the things that seem very simple and obvious for us, then slowly they become less and less obvious. So even though reaction times are a simple thing, and it makes sense what I told you about, like when responses should be slower, when they should be faster, it makes intuitive sense. It's still trying to understand why exactly is it slower, and when exactly might it be faster. Usually shows a very complex picture, and this is why I think that having like a mathematical modeling, like having a formal model of such mechanisms, can help, because these models are very, very complex and very nonlinear, and so and obviously the models themselves are a simplification. But yeah, not sure I answered
Yeah,
the question, but yeah, I just
yeah,
share some
yeah.
thoughts.
Sure. If you want to know exactly how these habits form, and these decisions are made in the brain, sure, it gets very complex, and you can go into the molecular detail, and how gene expression changes, and all these levels of complexity. But just to have something everyone can actually grasp in everyday life, I feel like there are many ways people try to address this, like how your emotions are, look, at all your muscles in your body, how you walk, how, all these complex AI models people try to build, looking, as I said, looking at where your eyes move, how your facial muscles move, how your tone is of the voice. But then you have this simple timing measurement, and it just says as much. I wasn't talking about how these thoughts processes work themselves. That's difficult neuroscience. But for this, just measuring the complexity underneath, but just measuring the symptom, and maybe modifying the symptom, the simple ways usually
Yeah,
of the.
yeah. Thank you. I completely agree. I think we always, like as scientists, we always need a good reason to use a very, very complicated and expensive method, in the sense that we cannot examine the same question using simple methods. And even more so, I think that it's really important to really sort of link in a very well informed manner the very complex variables we can gather using neuroimaging in general, or AI and neuroimaging, or whatever or the other possibilities you mentioned, to link them to people's actual experiences and actual behavior. It is something that is very important to do, and it is something that having, again, a formal model often helps with, because if you have some approximation of a mechanism, you can use this approximation to link different levels of analysis. So starting from brain, maybe even molecular, going to behavior, experience, and so on.
Oh, yeah, well, it's really fascinating, and we could probably talk on for years and never run out of questions in your research, because there are so many levels that we can talk about this. So I really appreciate you coming here and sharing your work. And there's so much to do. So maybe one of the last questions would be, what are you working on right now, and what are you planning, or what would you love to be working on, maybe in the very near future, because we want to follow your work and invite you back again. So if you could give us a glimpse.
Thank you. That's very flattering. So I'm will be working on exactly the same questions. I said that it wasn't just just a way to answer to difficult questions. We actually want to examine all of these questions about how we can what different types of variables and manipulations moderate proactive and reactive control over thoughts. We also want to examine even further this idea of how disorganization of thought and dysregulation of speech interact in a form of thought disorder in clinical and non-clinical populations. And in the most general sense, I really hope to continue investigating this very complicated and not well-defined issue that is, or thing that we call thoughts and how they work.
Well, perfect. Thank you. So we are looking forward to it's like the next episode. Waiting for the next episode. Yeah, it's a wonderful. Also, I think it's also always very encouraging to do these rooms. To learn like that. People like you are working on these problems to kind of ameliorate the human condition. That's always very positive in all these bad news out there, to have these rooms. So thank you, Isaac, and for doing this work. And thank you, everyone, for coming here and for being here. A special thanks to Katie today. You did a wonderful work moderating you made the room also. And Dr. Shanak, thank you so much for being here, and everyone else. And yeah, Isaac, as I said, you're always welcome back. Thank you for giving the time here, and please come back one day. Maybe I'll reach out to you next year or so. Thank you.
Thank you so much for inviting me. It has been really interesting discussion. And yeah, I mean, if anyone wants to contact me, please email me. Feel free. Any further questions, ideas. All of this work is very, in a sense, preliminary, and we're looking into every input we can get. So thanks. Yeah, thank you again.
Okay. Oh, go ahead.
Thank you. I was just going to say thank you for a great talk and a wonderful room. Really appreciate it.
Yeah, thank you. So we have actually another room later today. It was kind of a rescheduling thing that we kind of ended up with 2 rooms. So it's at noon EST today with Dr. Lana. He will talk about his rejuvenation work, and he focuses on T cells actually for rejuvenation. He started a company that is very promising, doing very promising work to find treatments to treat aging. And he is looking, he will talk about this recent work he published about intracellular transfer of telomeres in T cells. So he could transfer better telomeres that are longer in T cells, which is really exciting work. So yeah, I hope to hear you all back soon. And Isaac, again, thank you. And thank you, everyone, and talk to you soon. I'll close the room in 3, 2, 1. Bye, everyone. Thank you. Thank you.
Thank you so much.